Hello, people. This is Alexis Williams here for my Principles of Engineering class, period 3, from my team, the Classic 6, to present to you our Project 1.1.6 Compound Machines. Our design constraints. The applied force may only be provided by a single human input and must include a minimum of 3 mechanisms, including any of these simple machines: a gear system, a pulley and belt system, and a sprocket and chain system, although those are not the only systems we were allowed to use. The compound machine must have a mechanical advantage greater than 1 and be able to pull a kilogram weight up an inclined plane at a 45-degree angle. Our isometric sketches were these 3, which we designed in our brainstorming process. Our first isometric sketch was a sketch that we intended to use, which included a pulley system, a gear system, and an inclined plane. Our second isometric sketch included a wheel and axle system, a pulley system, and an inclined plane system. And our third isometric sketch included a lever system, a pulley system, and an inclined plane system. During our building process, we didn't meet our first 3 simple machine requirements because we did not include our inclined plane at first. We only had our sprocket and chain system, which was intended to be our gear system, but we couldn't find a gear chain for our gears in time, so we improvised and we used a sprocket chain and sprockets instead, which changed our gear system to a sprocket and chain system. And our pulley system was not set up how we intended for it to be because we couldn't figure it out in time. So we wrapped our pulley system in any way that we could. So we lined them all up from top to bottom and we wrapped it that way. And there was no way to attach the string to the sprocket chain, which we found out after we had built it. So we decided to make 2 sets of 2 sprockets using 2 various sizes. And we attached those 2 sprockets and chains with a wheel in the middle, which would wrap our string around it. It was harder to pull the string from the pulley side than from the wheel and axle side. And I say the wheel and axle side instead of the sprocket and chain side because without the sprocket and chain, our wheel would rotate just the same. But the sprocket and chain actually provided more support, so we kept them there. And our mechanism turned out to be more like our second isometric sketch rather than our first isometric sketch, and we had to add our inclined planes separately. So here we have it, our final isometric sketch using our inclined plane, our pulley system, and our wheel and axle system. Our mechanism's accomplishments and flaws. Using a human input, it rotated successfully and with ease, but we weren't able to calculate the actual mechanical advantage using a calculator because it was too much pressure on our mechanism. Our mechanism was too frail. The beams that connected the simple machines to the platform, they were loose and had no support whatsoever. And the fixed wheels within our pulley were not secure enough within the pulley system, and they detached easily. So our mechanism was too frail to pull the kilogram weight of the inclined plane as we wanted it to. And our overall ideal mechanical advantage was 36-to-1 ratio. How did I get that? The inclined plane was a 1-to-1 ratio, which would be right here connected to our pulley system, which gave us a 3-to-1 ratio with the 3 out of 4 pulleys in use here. And our wheel and axle system gave us a 12-to-1 ratio. The diameter of our sprocket here is a 1.5 inch, and the diameter of our axle here is a 1/8 of an inch. Multiply that 1.5 times that 1/8, and it gave us 12. So 1 times 3 times 12 gave us 36 with our overall ideal mechanical advantage. Here we have modifications to increase efficiency. If we would have added the cross beams to the bottom of the beams for support, they wouldn't have bent as easily. As you can see in this first image here, this beam is crooked. It is not straight like this one right here. And this beam over here, our wheels are not secure within the pulley system. As you can see, these are also crooked. Even though they're on a chair here instead of a table, they're already at an incline. But this is not crooked and it is not secure either. The string that we should have wrapped the string around in a more efficient way, but we wrapped it around in any way, and this is what the result was. We didn't have enough time, and this pulley came out once we pulled this from this side. And so we decided, that's when we figured out that we could only pull it from this side. And we should have attached the inclined plane directly to the rest of the mechanism and seen how it worked before we decided to build this and just add the inclined plane on whichever side, because it was harder and it created friction to add it to this side than it would have been to add it from this side. But this is my 1.1.6 project by Alexis Williams here, your narrator. Thank you so much for watching.